Hey everyone, welcome back to Breakthrough Innovation. We've got another great episode today, and with us is Michael Bar-Sinai, along with Preston Chandler as my co-facilitator here. Michael Bar-Sinai is a seasoned software engineer, researcher, and now he's also the co-founder and CTO of Provengo. Michael has spent the last 25 years building systems in diverse industries, from manufacturing control and airline software to societal impact systems and scientific tools at Harvard's Institute for Quantitative Social Science. His work spans privacy research, open source contributions, and formal methods in software development. Now at Provengo, he's pioneering software specification, testing, and AI guardrail tools based on formal methods. So in this episode, we're going to hit on a few topics. First, how is AI reshaping developer tools and software engineering? The challenges of turning theoretical computer science into practical tools for everyday developers. And then last, we'll talk about how to introduce disruptive tools into organizations resistant to change. So if you're looking to stay ahead of the curve in an AI-driven software engineering and testing world, you won't want to miss this episode. Michael, we really appreciate you being here. I'm excited to talk some computer science because it's been a little while. So it's great to have you on the show.
Great to be here. Thanks for having me.
Awesome. So Michael, when we talked a little bit about your history, it's clear you kind of made a recent transition, or maybe not super recent, but a transition from privacy research and academic projects to co-founding Provengo. What was the motivation? What made you transition?
So I was a software engineer for a while, actually started, working before I get my undergrad degree. And then at some point, on the boom and bust cycle, on myself sitting on a curb and thinking, well, that was fun. Maybe I'll do an undergrad. So I did my software engineering. And then somehow I got into the societal impacts of software for a while. And so I was doing some HR system. And at some point I realized this is, people, not just numbers.
Right.
So, and we had some weird algorithms there. So anyway, I was like, okay, let's look at bigger pictures here, which is a good thing anyway, I think, for engineers to kind of understand, like slightly above, get some peripheral vision of what you're doing. So I got a bit into privacy research, digital privacy, and then went back to academia, somehow against my will. Undergrad was intense, but I got talked into by the power that be to look into this software. I found these weird guys doing this weird thing called formal methods. And as a software engineer, as a practicing software engineer, I was like, okay, this is what like engineering software would look like. Because formal methods, I mean, it's something, it used to be a mandatory class in like most institutes I know. But it was taught as that this is the future of software engineering, and it's going to stay the future of software engineering for a long while. And like, you don't have to worry about it, just pass the exam. And the guys that I met at university had, formal methods to begin with. The idea is that you have like mathematically rigorous techniques for specifying a system. That's the idea. Specification, if you want to like look at this historically, is the one thing in software engineering that was not really disrupted. We started with waterfall with like really long texts, and now we're in agile where we have small text, but the text is just text. It's like it's tagged, it's in Jira, it's whatever, but you can still write contradicting stuff. You can write bullshit there. Nobody cares. Right. And at the end, you have developers who try to understand what they're supposed to do, and QA people who try to understand what they're supposed to test, and product people who try to understand how to properly specify everything. But because everything is just text, you can basically do stupid things and realize on production or after a very costly development process. So the idea of formal methods, which goes back to the 30s, right, is how to do something that's mathematically rigorous. So ahead of time, first of all, you understand what you're about to do. And then you can detect bugs in the requirements before the system is created. So this has been floating in academia for a long while, but it wasn't friendly enough for people to use. So it never got outside of academia. And when I came back to academia, I found this thing, but they were doing something called behavioral programming, which is, they even called it programming, not modeling or formal methods, because they try to not do formal methods because nobody does formal methods, but it was formal methods. And one time I was working with this system and I got into a race condition. When you have like the different ordering of bread and it's like impossible to debug. And then I realized I can actually use the formal aspect of it and turn the thing into a very large automaton and then find what happens. Okay, so it's like basically use the system. And it was so cool that I decided to make a technology out of it, basically. So we started doing some open source stuff, some tools, kind of like scratching the surface. And eventually ended up trying to bring this to the masses this time it's going to be nice.
So what does that mean for developers? I can see the benefit of formal methods, and I'm reaching back 20 plus years here to my CS degree, so I'm stretching. Yeah. And I can understand like how they work, and I even remember a little bit about it from my time in college, learning about it. Now that you've described it, the tools you're developing, like how do they impact developers? How are they being used, especially when we start talking about all the AI-driven applications that are coming out now? Like, where do the formal methods fit in?
So what you'd normally do is, first of all, you create a description of the intended behavior of the system before you write it. And just doing that would make you disambiguate a lot of things that you'd find out during production or very late in the development cycle.
Are you talking like non-functional requirements like performance, or are you talking about other things that are more specific specifications of what the system is supposed to accomplish?
So mostly specifications. So things that sometimes, there are all kind of combinations. Maybe you're doing some enterprise software and there's like normal customer, and then there's like a platinum club customer, and they're supposed to do something else or this kind of thing, especially when you get into regulation stuff. So if suppose you work in a bank and there's this KYC regulation, right? You need to know your customer before you can transfer funds into it. So the classic case would be that some guy in product says, let's do a fast money transfer. And everybody are so happy about doing things fast, they forget about this regulation. And then, the regulator calls and it's like, so for the last 2 years, you guys have been violating this KYC thing. And we'd like you
to make it right.
Exactly. Make it, yeah.
This sounds to me a lot like test-driven development, like maybe on steroids, but test-driven development approach where you've created this model of this is the total output of the system. And now we're going to just build stuff that continues to satisfy what we expect from the system. Is that?
Yes, that's especially the on steroids part, because what it does, it generates. It's a good way of putting it, but this is when you apply it to test. So you have this model, which is basically a very large state machine, okay, of how the application behaves or how it should behave. Based on what the environment does to it. Okay, so I don't know how it's implemented. It's not implemented even at this stage.
Yeah.
But you know what's going to happen. And then a test would be basically just a walk along this automaton, right? So you have infinite number of tests, basically. If you have loops, it's actually infinite. If not, it's just hundreds of thousands. And then what you can do is you basically automatically generate an optimized test suite, because you have so many of them. You just generate it. And so if you're doing testing or automated testing, you just add more data to it, like automation data, stuff like that, then it just works. But even if you don't do the testing, if you just sample a few cases, a few paths, and just show it to the product people and say, okay, this is what we're about to build. Are you guys okay with it? And you can show it to legal, to compliance, all these guys. You can actually check that no paths in this graph violate company policies or regulations, stuff like that. And once AI comes in, AI just basically makes you faster, right, as a developer. It doesn't make you more accurate.
Right. It makes trash faster. if that's what
Exactly. So
Garbage in, garbage out.
yeah, because I mean, first of all, it's actually backed by research that it accelerates software, but it accelerates value generation more. Because if you think about the way AI, I mean, maybe it's an interface thing, but it involves one thing that developers love, which is moving faster, and two things that developers hate, which is explaining what needs to be done and then going over someone else's code.
Right. Yeah.
So if it's junior, he types, just do that. Here's the code. It looks good, right? And it goes in production. And there's actually less sense of ownership of what's happening there because the AI did it, must be good because it contains AI there. So it's kind of like taking a normal car and putting a bigger engine, but not enforcing the wheel and the brakes.
And so formal methods are like basically your way of building up the brakes, the wheels, the I don't know, I'm not a car guy. I was about to really expose my lack of knowledge of cars by saying something that probably wasn't right. But basically helping the car support the more powerful engine.
Exactly.
And notify when changes in the car mechanics or in the car setup is actually going to drive to a crash. Be like, no, that mix doesn't work. That violates some system truth. Yeah.
Exactly. Yes. You're
So
about to do, I mean,
basically,
at the top, like when you get to the full usage, when your specification is about to break some company policy, it actually breaks the build because it doesn't pass verification. That's like,
so you're creating tools that let organizations more safely build AI-driven tools as they move forward and as AI becomes more capable.
yes,
I
basically
love
first.
it. Now, when you think about that, what does that look like in the next 5 to 10 years? Like, where are things going with this AI-driven development, formal tools? Like, what do you foresee developers doing 5 to 10 years from now?
I guess we'll see more agentic AIs, right? Because this is what is being forcefully driven now. And they need to be guarded at some point because you can't, I mean, here's the thing about which I think is going to need to be corrected somehow. Probably after we'll get into some a boom and bust cycle of AI systems. English is not, I know that a lot of people say that like, English is the next programming language. It's not built to be a programming language. Whenever you do something that's really accurate, it's not English. I mean, I don't know, maybe one of you guys is a lawyer, but if you get like a contract, right? Maybe buying a house or a car, I don't know. You have a lawyer look at it, right? Why? Because even though it's in English, you can't read it unless you're properly trained. Because English is not accurate enough to do stuff like enterprise software. I mean, it just
Medical
doesn't work.
devices, avionics.
Yeah, exactly. So we need the equation. There's a reason that there's mathematical notation. There's a reason that formal languages, like programming languages, exist. So we may be able to kind of like lower the boundaries, allow people to do more, but it's not going away because doing a full specification of something in English just will bring us back to waterfall, right? We'll have this huge amount of, I don't know, long. There won't be printed papers. There'll be Word documents or like Google Docs, whatever. At the end of the day, if page 5 contradicts something on page 300,
No one will find that.
no one will, well, the users will, or
eventually, that's true. Your users will find it, you won't, and that's the risk.
Exactly. And this is where I think would be the time for something more formal to say, okay, you know, we need to be able to combine the creativity and pushing forward of Gen AI, but they'll have to be guarded somehow. I obviously believe that formal method would be the good way of doing it, but even if it's not formal method, something will have to make sure they don't act on not even hallucinations, just ambiguous documents given to them in English.
That
Well, and it's interesting. There's so much hype around AI these days that everyone seems to look at AI as the solution to every problem. I think it's good to add a little bit of caution to that in terms of when you really need precision, you need something a little bit more, some better guardrails. And I think I agree with your prediction. In the next 5 to 10 years, there's going to be probably some spectacular failures, for lack of a better term, where those guardrails weren't in place.
Yeah. There have to be.
Some hard lessons are going to be learned. Interesting.
Mankind has this history of inventing the chainsaw and only then the safe on the chainsaw.
Yeah, exactly. Someone's going to lose a thumb and we'll learn a lesson.
Mm-hmm.
So, Michael, if anyone's looking to get some help with formal methods and moving forward on AI projects, what's the best way for them to get into connection with you and collaborate with you?
So I'm on LinkedIn, right? So I've this LinkedIn account, and I'm available at provengo.tech. So Michael at provengo.tech, and we're looking for design partners and early adopters that are brave but like good quality system.
Perfect. No, I love it, Michael. I really appreciate all the time and all the insights for today. I know we have a lot of listeners who are probably here at the end as well. And I want to thank them and encourage everyone who's listening to leave a review on whatever platform that you're listening on. And then if you know anyone who needs some support in implementing AI-driven tools and who could benefit from some security and formal methods, pass this episode on, share the wealth, introduce them to Michael. And then lastly, go back, listen to the episode one more time if you have the time. Pick out an insight, something actionable, take some action and let us know how it goes, because we're firm believers in that whole form of continuous improvement, whether it's personal or organizational. And then lastly, again, thanks for listening. Michael, thanks for being here, and we'll see you all next time on Breakthrough Innovation.
Thanks, Michael.
Thanks for having me. Bye.